Lesson number 73 is about factoring the difference of two squares and probability without replacement. Now, factoring the difference of two squares, we've got an example of that here, because we can take the square root of both of these numbers to help us factor the problem. So the square root of x squared, well, that would just be x, because x times x is x squared. So the way that we're going to write this is we're going to say x squared, because when we find the square root, we want to put it in parentheses. Then we're going to find the square root of 4, and that's 2. And we're going to get 2 squared in order to help us get back to 4. Now this is an intermediate step, and this intermediate step helps us to find the answer because it tells us what our binomials need to be in order to multiply to get to x squared minus 4. So those two binomials that we're going to multiply, because whenever we factor we're going to have things multiplied together to get us back to our answer, will be x and 2. And in order to have a positive x squared, we've got no x term and a negative 4 is going to be to have one positive value and one negative value. So our answer will be x plus 2 times x minus 2. And if we look at this to see why it works, it'll make more sense. X times x is x squared. That's good. That's what we started with here. That's what we want. Then we get plus, well, FOIL, so we're going to go on the outer. So we get minus 2x. Then our inners, plus 2x. Our last numbers, minus 4. So we get x squared. We have 0 x's, minus 4. And we came back to our original problem. So that means we've factored this correctly. X plus 2 times x minus 2 is our correct factored form for x squared minus 4. Let's look at another one. Here we have 49m squared minus a squared. So we've got to find the square of what squared gives us 49m squared. Or what's the square root of 49m squared? That must be 7m. And then we must have to square that. Minus, well, the square root of a squared is just a squared. Now we can write our two binomials. And we know the terms that have to be included are 7m and a. One of them needs to be a positive, the other needs to be a negative. So we're going to get 7m minus a times 7m plus a. And we've got our final answer. That's all that we need to do in order to solve this one. We've got one more like this. Let's factor. We've got negative 36 x to the 6th y to the 4th plus 49a squared. Now if we want to factor this one, let's rearrange it. If we arrange it so our positive number is first, it's going to make it easier to look at. So we're going to get 49a squared minus 36 x to the 6th y to the 4th. That last one should be a y. Now if we do that, 49a squared is just going to be 7a squared. Because if we said 7a times 7a, we get back to 49a squared. Then from that, we're going to subtract. Square root of 36 is 6. The square root of x to the 6th power, well, x to the 6th power, if we look at that one, is going to be x to the 3rd power, because x to the 3rd times x to the 3rd is x to the 6th. Square root of y to the 4th is y squared. And now we can go ahead and write as two binomials. We're going to get 7a minus 6x to the 3rd y squared as our first binomial. And our second binomial is going to be 7a plus 6x to the 3rd y squared. We've got our final answer. The key to these problems is recognizing when you have two squares or difference of two squares with addition and subtraction. Then you can go ahead and find their square roots and write them as two binomials, one negative, one positive. We've got a type of probability problem in this lesson as well. Let's look at it. A container contains 4 red marbles and 7 blue marbles. Let's draw that out before we continue today. So we've got 4 reds and we've got 7 blue. Two marbles are drawn at random. What is the probability that the first marble is red and the second marble is blue if the marbles are drawn A, with replacement, and B, without replacement? Now, to have the marbles drawn with replacement means we put them back in before the next time we draw one. If there's without replacement, it means we keep the marble out of our container before we draw the next one. So two marbles are drawn at random. What is the probability the first is red? We'll do problem A first with replacement. So the first one to be red, we can see we've got 4 chances out of a total of 4 plus 7, that's 11. So what's the probability that the first is red and the second is blue with replacement? So we put the red marble back in. We're going to have to multiply this times the second thing, and that's the probability that the second is blue. Well, the probability the second is blue is 7/11ths because we put the red marble back in, so there were a total of 11 the second time around. When we simplify this, well, we see we can't simplify before we multiply, so 7 times 4 is 28, and 11 times 11 is 121. So this is the probability that the first marble will be red and the second marble will be blue. 28 out of 121 tries. Now, if we look at the next one, problem B, what's the probability that the first is red? Well, it's still 4 out of 11. And we're going to have to multiply that times the second probability to find our answer. But this one's without replacement. So if the second one's without replacement, it means we took a red out and we didn't put it back. If we took a red out and didn't put it back, the probability that we're going to get a blue the second time is going to be 7 out of 10 because there's only 10 marbles left. We kept that red out. So let's go ahead and find our answer. We'll simplify before we multiply to get 2/5 instead of 4/10. So 2 times 7 is 14, and 11 times 5 is 55. So we've got our second answer. It makes a big difference if there's replacement or not replacement, and you can see that in our final answer. Lesson practice will be on page 300. Make sure you've got your notes complete, and I'll see you during our next class.